Okay, so I just want to review simplifying radicals quickly. So one thing that I always like to have handy in my brain is a list of my perfect squares. So I won't always have this written out, but I keep the numbers fresh in my mind. Okay? It is true that 0 and 1 are both perfect squares, but they're not really going to help me when I'm simplifying radicals, so I'm not going to include them on my list. I like to start with 4. 2 squared, 3 squared, 4 squared, and so on. So I like to go up to 15 squared. This is not a list that you need to memorize. You can always just recreate it. I just have 2 squared, 3 squared, 4 squared, 5 squared, and so on. But you want to familiarize yourself with these numbers. When you see the number 81, I want you thinking, oh, that's a perfect square. When you see 49, oh yeah, perfect square. So these numbers should always be setting off bells in your head. Yep.
Shouldn't it be 194, not 197?
No. It's always, well, I just know it because it's these just two swapped. But yes, because that's 14 times 14. So 4 times 4 will get you a 6. Oh, no. There goes Albert. Okay, so remember how these work. It's kind of like you're reducing fractions almost. So if I asked you to simplify the square root of, oh, I don't know, 50. Oh, dear. You could ask your calculator to turn that into a decimal all day long. It's actually a very common MCAS question. They'll ask you, between what two integers is this square root? Between what two, if I were going to do it on my, between 7 and 8, right? Because 7 squared is 49 and 8 squared is 64. 50 is in between 49 and 64. So that means if I did it on my calculator, it would spit out 7 point something. Probably be really close to 7, right? Because the square root of 49 is 7, and I'm only one more higher than that. Anyway, I'm not going into decimal, but it's helpful to kind of keep in your mind, all right, this is about where I would be. So, do you remember what you do to simplify these? You need to look for a perfect square that divides evenly into your number. Preferably the largest perfect square in this list that divides evenly into 50. What would it be? 25. So I split this up into the square root of 25 times 2, because 25 times 2 is 50, right? But look how nice this is. I know the square root of 25, it's just 5. So I get 5 root 2. Thanks. So that's how you say that out loud, 5 root 2. So if I took my calculator and I actually did 5 times the square root of 2, well, I'll show you. Why just show you when I can? 5 times the square root of 2 gets me that crazy decimal, which is about what we were expecting, really close to 7. Or if I just do the square root of 50, they're going to come out to be the exact same number. Just like if you did 4 divided by 8 or 1 divided by 2. Isn't it the same fraction, just reduced? Right? 4/8 is the same thing as a half. So when you plug in either one in the calculator, you're going to get the same decimal. So it's the same thing. We're just simplifying the radical. So if you have a number underneath the radical that a perfect square can divide into, you need to simplify it. Okay? That's same rules like with a fraction. You're never going to write, let's say you're taking a test and the answer is a half. You're never going to write 5/10, 5 over 10 on your answer sheet, right? You're always going to reduce. Same thing with radicals. If you have a radical, you reduce the radical if you can. All right? So, I don't know. Let's try, you do this one. How about square root of 300? Do you remember doing these? Okay. So you're looking for the largest perfect square that goes into 300. What is the largest perfect square that goes into 300? 100. So this would get split into 100. Square root of 100 times the square root of 3. And what is the square root of 100?
10.
Just 10. So you get 10 root 3. Now, I want to show you what happens when you don't pick the largest perfect square. So let's go back to 300. Doesn't 25 go into 300? It does. And 25 is a perfect square. How many times? 12. So here I'd get 5 root 12. Well, that looks a lot different than 10 root 3. Guess what? If I type both of these in on the calculator, they're going to be the same.
Factor out from 12.
Exactly. The problem here is that 12 has a perfect square factor, 4. So this is not fully reduced, if you will. I have to simplify this again. 3 doesn't have any perfect square factors. So this one's done. I know this one's finished. But this one, you'd have to do it again, right? Square root of 12 can be broken up into the square root of 4 times the square root of 3. What operation is between the 5 and the...
Multiplication.
Yeah, it's just multiplication. So I can just bring that down. So that would be 5 times 2 times the square root of 3. I eventually get 10 root 3. But my goodness, you literally did twice the work. Why would you bother? So it's in your interest to take an extra 10 seconds and make sure that you have the largest perfect square that divides into a number. Okay? And if you're not sure, don't continue if you see that this number also has perfect square factors. So let me give you, let's do a tougher one. How about, say I ask for the square root of 864. Okay? At first glance, maybe you know some numbers that divide in, maybe you don't. Certainly 2 does, right? Can you do better than 2? What do you know divides into 864? Do you guys know your divisibility rules?
Don't you? 8 goes.
8 does? How do you know 8 goes in?
Quick math.
Because the rule for 8 is actually if the last 3 digits, so in this case it is a 3-digit number. So if it was like, the rule for 4 is the number made by the last 2 digits, so 64. If 4 can go into 64, then 4 can go into the whole thing. 8, the rule is the last 3 digits. So in this case, the rule doesn't really help you that much. But it is easy math because 8 can go into 800. And can 8 go into 64? Yeah, so 8 does go in. Let's just try 8. When I divide 8 in, let's see how far I've gotten. So 864 divided by 8 would leave me with a square root of 108. Does 108 have a perfect square factor? 108? Oh, 9. I didn't think of 9. I thought 4 right away. But 9 works. Now look, I already took out an 8, right? I took out an 8. If 9 goes in, that means 8 times 9 goes in. So that's a 72. So 864 divided by 72, I get 12. I'm getting closer. But 12 still has a perfect square factor of 4. So now I can take the 4 out and put it here. So 72 times 4 is 288. Does that go into 864? Yeah, 3 times. Oh, but that's not a perfect square, so that didn't help me. That was silly. Oh, but I'm right there. I do see 288 is just what perfect square. There's a perfect square right there. It's just doubled. 144. Yes, 864 divided by 144 leaves me with a 6. There it is. 144 and 6. So although 288 and 3 go in, 288 is not a perfect square, so it's not going to help me. But 144 is. So I get 12 root 6. Okay, so you kind of remember doing this at some point in your life? Simplifying square roots? Maybe a little bit? Let me give you one to try without me talking. You just try it. Give me the square root of 75. Square root of 75. Thanks. Did you get it? You got it. Biggest perfect square that goes into 75 is 25. So I get 5 root 3 in the end. Okay? Now, we already kind of mentioned what happens when there's a number out in front. So if I asked you to do, I don't know, 8 times the square root of 72. This 8 just means I'm going to multiply whatever number comes out in the front by 8. Okay, so really at first I don't do anything different. I'm still just trying to find the largest perfect square that goes into 72, which would be what's the largest perfect square that can go into 72? 36. So I split that up into 36, square root of 36, square root of 2. And now, just watch how my numbers work. 8 is still 8, but the square root of 36 is just 6 times square root of 2. So my final answer is 48 root 2. So if you have a number out in front, I mean, don't get all worked up about it. You just multiply the numbers together in the end. Yeah.
You know, 36, it's like it could be -6 and 6.
Mm-hmm.
Would you ever do a negative?
Great question. So here's basically how this works. If you see this written on your paper, this notation is really just asking you for what we call the principal root or the positive square root. So it is true that the square root of 9 has 2 answers, positive 3 and negative 3. If I want both roots, you're going to see it written like this. So that would indicate, give me both roots that work here, positive and negative 3. And if I just want the negative root, you're going to see it written like that. Okay? So when we are writing it with nothing in front, we are just asking for the positive root. But that's a great point. When we are solving quadratics, like let's say I give you this, x squared equals 81, right? How would you get x all by itself? Like how do you undo squaring something? You square root something. If you take a square root, you have to remember both roots, right? This one, you have to know that I want to take both roots out of this. So anytime I'm taking the square root of a number, and it's not already written like this for me, I need to know that I need both roots. Because if I give you the equation x squared equals 81, and you don't tell me positive and negative 9, you're only giving me half the answer. Good question. So that'll come up a lot as we're solving quadratics. But if you are just simplifying a radical, if they don't have the sign in front, you can assume it's just the positive or principal root. Okay? Let me have you try one more with a number out in front. In fact, let's make that number negative. Why not? How about negative 3 square root of 450? Try that one.
So did you know when we get progress reports?
Nope.
Is it negative 75 right?
No. Negative
15. I thought it was 20.
Yeah.
15 times 3 is
45.
45.
So 450 has 25 goes in, but that's not the biggest. So if you had started with 25, right, and you do 450 divided by 25, you get 18. Well, 18 has a perfect square factor, so that means that's not the biggest one. So keep looking. It happens to be 9 that you can take out of that. So 450 divided by we get 225. So we're going to split this up. Negative 3, square root 225, and the square root of 2. So if I just do my math, negative 3, the square root of 225 is 15 square root 2. So that is how I arrive at negative 45 root 2 in the end. Yeah, we're all right? Okay, so one more thing I want to talk about before lunch. How do you handle square roots of fractions? Yep.
So you just do the square root of the top and the bottom.
That's it. So the square root of 1/4 is just 1/2. When you take the square root of a fraction, you're just going to break it up and take the square root of the top and the square root of the bottom. So it's convenient when top and bottom are perfect squares, right? You just get 1/2. So if I want to take the square root of, 49 over 121. It looks awful, but it's really not bad at all, and it just comes out to be 7/11. What happens when it's not so nice? Say I wanted the square root of, how about 5/16? That's it. It becomes the square root of 5 over 4. Now, we run into trouble when we are left with a square root in the denominator. You are not allowed to have square roots in the denominator. So what we need to do to fix it is called rationalizing the denominator. Because the square root is of a weird number is an irrational number. So I need to make them rational. So do you remember, so let's just flip this around. Say I had asked you for the square root of 16/5. Well, the beginning part's easy. That just gets me 4 over the square root of 5. Do you remember how to fix this? How?
Multiply by
Yes, now here's the thing. You can't just go around multiplying things by anything except for, what am I allowed to multiply a number by without changing its value?
1.
1. I can multiply a number by 1 and not change its value. So what I have to do is multiply by the square root of 5 over the square root of 5, because isn't that just 1? Right? Same thing on top and bottom in a fraction. It's just 1. So I'm not changing the value of 4 over root 5. I'm just trading it in for something that I can use. I'm trading in my 4/4 for the dollar. Right? Same value, but so now what is square root 5 times square root 5? It's the square root of 25, which is just 5. When you square a square root, it undoes itself. So do you remember doing this now that you see it? Right? So that would be a number written with a rationalized denominator. Try one before lunch. Ah! Dang it. That always happens.